Safety glasses, don't forget them. They're an essential part of your day. When you go into that hazardous area, you gotta have your safety glasses on. Don't forget. Whenever entering a hazardous work environment, make sure you have your safety glasses on properly, not in your pocket, not hanging on your shoe collar. Your welding helmet, you gotta have it. You don't have to buy it from Lincoln. You don't have to buy it from Miller, the two popular welding companies, but you may find one that is cheaper online, but I would not buy the real cheap ones that are, like and on Amazon, stuff like that. Go to a reputable dealer. Inside your helmet, okay, always keep it clean. Make sure it's sanitary, dust-free, your headgear is adjusted properly, and your switches will tell you, or I should say your buttons will tell you which way to go for everything. Now your switches, your first one is going to be set at 6 o'clock. Your second one is at 6 o'clock. The third one, which is the shade, I use at a 9, but normal standard settings for industry is it comes as a 10 is what is usually recommended. I weld a lot of low amperage TIG welding, so it's not very bright, and I'll go through and keep mine on a 9, and that seems to work the best for me. Your TIG gloves, okay, we talked about them a little bit earlier. I have my name on mine. You see that. Somebody else steal them if you don't. These things are not that expensive, but once they get broken, they feel pretty good. They're made really well if you get a good brand. You see here the leather reinforced seam. Okay, the precision Kevlar stitching. A lot of your other gloves don't have Kevlar stitching. It's just a regular cotton stitching. If your gloves get wet or sweaty like that, then they will not go and stay together very good. They start falling apart pretty easy if you get them wet. The leather reinforced thumb works good for holding onto the rod and making sure that the rod doesn't poke you in the hand and stuff when you're welding with it. The welding jacket, it'll say here that you can wash it several times, but I don't recommend washing it as long as you can prevent it. A lot of times washing it will remove the flame retardant that's on your jacket. Even though it's a cotton jacket and resists catching on fire, the flame retardant being removed will make it even more readily available to a flame when you need to, keep it flame retardant. As you see your jackets here, they are, cotton, lightweight, breathable fabric, and it says machine washable up to 50 washings. I'm a little skeptic of that number. I've never washed a jacket 50 times and had it survive that many times. I don't really recommend washing it, as I said earlier. I would go through and try and just keep it clean, let it air out as often as possible, and then wash it once, maybe twice, no fabric softener. Okay. We're going to put our gear on and we're going to run some beads. Putting on my TIG gloves. I'm not welding a lot. Yes, I know I get some flack about not having sleeves on. I don't have sleeves here. I don't use sleeves. I've been doing this for 30-some years. I've got a pretty good tan build up there. Not the safest thing in the world, I'll admit that. Okay, so I got my welding helmet and my safety glasses. I have my ventilation on for the shop, and I have my light shining. Okay, the machine is on. My foot pedal is down here. The whole principle about this is when you put your tungsten down here on your metal, okay, you're going to touch and hold your spot. Touch and hold your spot, okay, and then you're going to lift it up about 1/8 of an inch. Okay, we lift it up about 1/8 of an inch, and then you're going to push your pedal down. And and you'll hear the gas start blowing out. Many people may think you're going to use the same gas as MIG welding. Of course, stick welding doesn't use it. Flux core uses a gas sometimes. MIG welding uses usually a 75-25 for short arc. This for your when you are TIG welding, okay, you're going to use 100% argon. There are some other gases you can use, like 100% helium and stuff like that. That's extremely expensive. 100% argon is a common one you'll find in the factories. Okay? All right, let's lay a bead. I'm going to get my hand set. I'm going to get my other hand set. I'm going to do my nod. Somebody turn off my gas. Nope. Gas on. Okay, somebody welded some crap here. Starting here. Remember, once again, this is a 2x6 inch plate, 1/8 of an inch thick, 6061 T6, aircraft aluminum. One of the most common aluminums you'll find in factories, RV industry, stuff like that. Our filler rod is a 5356 aluminum. I'm using a 3/32 filler rod, which is 3 foot long, 36 inches. And I'm using that right there. We've got our plate going here. And I'm going to run a bead, get the machine set up so it's working good, and then I will come back and explain more on the pad assignment. We're going to get the machine set up right now. Test plate number 1. Okay, as you can see on these beads that I ran, some of them don't look very forthcoming there when you look at them. They got some porosity, inclusions and stuff in the beads, a lot of porosity due to my gas problem. I had a little bit of a gas problem at the beginning. I wasn't up to the proper PSI for my argon. When you do a setup for a machine, you want to make sure that you are anywhere from 15 to 20, 25 PSI for your argon. It also depends whether or not your space is windy. If you got any kind of breezes or anything through there, you need to try and block that breeze with a curtain or get you a bigger cup, maybe switch to a gas lens, something like that. As you can see, the far back plate is the one I started out on. I'm trying to run some beads, and we're just not quite getting there. Okay, we're ready to weld. I've done some beads. Ventilation's on, lights on, my helmet's working. I'm ready to go. Here we go. one bead. Now we're going to overlap them 1/4 of an inch on each bead. So I'm going to add some more here. Okay, here's 2 of the beads that I just finished. As you can see how one lays over the other, about 1/4 of the bead is overlapping. This is your first start going onto your pad. You're just going to continue that layering going across it, and then you'll do, it's going to be 6 to 8 beads on the long ways, and then about 21 beads on the short way, and then back 3rd layer is long. We'll start doing our wrap up here. This is not that hard of an assignment, but it's one that is commonly done when you first start out your basic TIG welding. You want to be able to run a bead, okay? Usually a 6-inch bead is plenty for most of your welding jobs. Once you do that, you're going to be able to start on not just your flat welds, but your vertical up welds, your horizontal welds, your overhead welds, okay? And then you move on from like sheet metal, move on to your different types of pipe and stuff, and different bevels, different thicknesses of pipe, and then welding sheet metal to pipe for certain certifications, stuff like that. Okay? Thank you. Okay, I want to show you a sample of some of the welding that my students have done for the pad. This part right here, this first plate right here, would be a pad. You see how we got the beads all one after the other in the area here, and then they overlap. About a quarter of each bead overlaps to the next one, and you're going to have 6 to 8 beads go across that. Okay, and then you're going to do a third layer. You got to finish this one. This is just practice one. You're going to do a layer short all the way across, overlapping just like you did the first layer, and then you're going to come back and finish with a third layer on top of the long. So it's going to go long, short, long. Okay.